Hello again. So we are Unit 2, Lesson 3, page 9 of your note packet. This is function composition. So the first paragraph says, since functions convert the value of an input value into a value of an output variable, it stands to reason that this output could be then used as an input to a second function. This process is known as the composition of functions. In other words, combining the action of two rules of two functions. So we have to find one and then plug it into the other. So exercise 1, a circular garden with a radius of 15 feet, is to be covered with topsoil at a cost of $1.25 per square foot of garden space. So the first thing we need to do, part A, is determine the area of this garden to the nearest square foot. So we have to take our 15 feet, that's the radius. Okay, so the area of a circular garden is pi r squared. So r is 15, so we put in 15 for r, and we get 225 pi, which is approximately 707 square feet. Okay, square feet. Now, using your answer from A, calculate the cost. So the cost is $1.25 a square foot. So we're taking this 15 feet was the first input value, and we received an output value. Now this 707 is going to be an input value times the 1.25 at a cost of $883.75. So we can see, let me just move this down. In this exercise, we see that the output of the area function is used as the input to the cost function. So this idea can be generalized in functions f and g as shown in the diagram below. So your input x, which was in this case the 15, okay, is an output, which becomes the new input, okay, to g. And then your final output, because it's a composition of functions, you plug in twice. So there are two notations that are used to indicate composition of functions. These will be introduced in the next few exercises, both with equations and graphs. These here, exercise 2, they give you the f of x, function of x, g of x. They're both functions, but to differentiate between the two, one is f, one is g. Find the value of each of the following. Now, what has to happen is you have to do your parentheses first. So we have to do inside parentheses first. So you can see that we have to find the f of g of 1. So in order to do that, we have to find g of 1 first. So g of 1 is 2 times 1 plus 3, which gives us 5. So that is g of 1. So g of 1 is 5. And so we're plugging in f of g of 1, so f of 5. So we have 5 squared minus 5, okay, which gives us 20. Okay, so you're substituting in twice to get the final output value. For the second one, f of 2, I plug in the 2 for f of x, so I have 2 squared minus 5, gives me a negative 1. And so my f of 2, which is right there, is negative 1. So I have g of negative 1 is 2 times negative 1 plus 3, which is 1. You need to use your calculator, use your calculator. So g of 0, is 2, 0 plus 3, which gives me 3. So g of 0 equals 3. So now I have g of 3. And g of 3 is 2 times 3 plus 3, which gives me a final output of 9. And 3 more. Why don't you try these 3? Okay. Plug in first. Okay. Well, actually, I see there's something different. So you see how it's fog? Okay. I call it fog and goof is what I call it. Okay. So all it means, it's the same thing. All it means is f of g of negative 2. That's all it means. So it's the same exact thing. So you won't have to, don't do it alone. Don't do it. I'll help you. Okay, so that means we have to do the g first. Okay, so my g, I'm out of space here for some reason. Let me extend the page. Okay, there we go. So my g of -2, all right, where's that equation? So then I have 2 times -2 plus 3, which gives me -1. And then my f of -1 is -1. Now, be very careful here. It has to be in parentheses because it's squared, minus 5, which is -4. So that's my final output value. Okay, so here we are again, g of f of 3. Okay, so if you want to make it look like the previous 3. So we do f of 3 first. So we have 3 squared minus 5, which is 4. And so that's here. So now we have g of 4, which is 2 times 4 plus 3, and it gives me 11. And then the last one, f of -1. F of -1 is -1 squared minus 5 for a -4. And then f of -4 is -4 squared minus 5 for 11. And you have to be careful. If you don't put that in parentheses, it's going to give you a -16, which is incorrect. Okay. Moving on with, hopefully, exercise 3. Okay. Okay, exercise 3 deals with graphs. So you have 2 functions, f of x and g of x, and one's a line, one's a parabola. So you're looking at the output values based upon a graph. So for the first one, I have g of f of 2. So same process, you find f of 2 first. So f of 2 is the line graph. So my input is 2, my output is 3. So here's 2, and I go up to 3. So then I want to find g of 3. So g of 3, 1, 2, 3. My output is going to be 3. So you use the graph. And you just look at the x values, and then the corresponding y values are the output values. So the next one I have g of -1. So here's my g, -1 brings me down to 1, 2, 3, 4, -5. And then f of -5. 1, 2, 3, 4, 5, looks to be at -1/2. So you gotta be careful. That 1, 2, 3, 4, 5, we're right about there. So it looks to be the half, -1/2. Next one, we have g of 1. So g of 1 brings me to 3. And then g of 3, here we are again, 1, 2, 3, gives me an output also of 3. Okay, as you look at the graph. Now you're still looking at your graph. Okay, I lost mine, so I have to look at my paper. So same process, all right, let's rewrite it. G of f of -2, like that. So it looks just like the other one. That's at -2. So I have f of -2, which is 1 based upon the graph above. And then you have g of 1, which is, I don't know what happened here. There we go. G of 1, which equals 3. Okay, and then f of g of 0, so we have f of g of 0. So g of 0 is going to be 0. F of 0 is going to be 2. That's your final. Next one, f of 0. F of 0 is 2. And then f of 2 is 3. Okay, again, just all looking at the graphs. Okay, we're on the last one, page 10. We're on page 10 still. On occasion, it's desirable to create a formula for the composition of 2 functions. We see this facet of composition throughout the course as we study functions. These next 2 exercises illustrate the process of finding these equations with simple linear and quadratic functions. So what that means is we are not going to have actual numbers, but we want a rule if we have an f of g of x or g of f of x. So exercise 4, we're given the function f of x equals 3x minus 2. and g of x equals 5x plus 4. So we want to determine the formulas in simplest y equals ax plus b form. Okay, so what we need to do is we have to take our g of x. So g of x is 5x plus 4. So we have a f of, that's a 5x plus 4. So wherever we see an x in the f of x, we have to put in that binomial. So we have 3 times 5x plus 4 minus 2. So wherever there was an x, you put that binomial in. So we have 15x plus 12 minus 2, which gives us a result of 15x plus 10. Okay, and then it says y equals ax plus b form, so you have y equals 15x plus 10, and that would be your rule for that composition. Now going the other way, we take our f of x, which is 3x minus 2, and we're going to put it in for the x in g of x. So we have 5, 3x minus 2 plus 4. So we have 15x minus 10 plus 4, which gives us 15x. So we have y equals 15x minus 6, and that's your rule. And then with a quadratic as well, if f of x is x squared, this is exercise 5, and g of x is x minus 5, then f of g of x, so my f of g of x, because g of x is x minus 5, that has to go in for my x in f of x, so I have an x minus 5 quantity squared. Now be careful of that. Okay, that's not just x squared minus 25 or x squared plus 25. You have to box it. Remember your box. So x minus 5, x minus 5. So then we have x squared minus 5x minus 5x plus 25. So it should be x squared, the peanut, minus 10x plus 25. And go back up and see what choice that is. And that is choice 4. X squared minus 10x plus 25. All right, well, that's all I'm going to have time for today. In class, we will finish up lesson 1, lesson 2, maybe discuss the test if everyone has completed them, and we'll work on the fluencies in lesson 3. Okay, we will see you in class.